This is video number 4 for sections 7.4 and 7.5 using the quadratic formula. Now that we have the formula, let's work out some demo problems. So I've given you here a quadratic equation, and we are supposed to solve for x. If you're going to use the quadratic formula, the first thing you have to do is you have to put the equation in that standard form, which basically means you have to get a 0 on one side. We said you don't want to have any fractions, and you want to make sure your a is a positive number. Essentially, it's the same format that we used for the factoring method. Just make it ready for the factoring method, and you're ready for the quadratic formula. In this example problem, it looks like I need to distribute to get rid of those parentheses. There's no parentheses in standard form. And let's see, I need to get everybody on the same side. I know I want the a to be positive, so I'm thinking what I should do is I should move these guys over to the right. And if I do that, then I will have what I want. Let's write down what we have now. Okay, so now I'm in standard form, and I'm ready then to go to the formula. Remember, it is just a formula. This is telling you if you want to find the solutions to this equation, just plug in to this particular formula. Now here's what I would suggest you do in terms of writing down the work. I would suggest that off on the side somewhere, you just list for yourself what are the a, b, and c. You read them right off of the equation. They're just the three coefficients. So the 4, the -2, the sign matters, and the -1. And then go to your formula. And there's so much going on in this formula that one way you can really help yourself is by using slots. And what I mean by that is write the formula down like this each time. Negative slot for that first letter, plus or minus the square root of slot squared minus 4 slot slot all over 2 slot. I'm just replacing each letter with a slot. That's what it's there for. All I have to do now is stick the A, B, and C values into their appropriate slots. I ended up with 1, 2, 3, 4, 5 slots. That's because in this formula there are 1, 2, 3, 4, 5 letters. The first slot, going back to the formula, is a B slot, so I fill that in with a -2. The next slot is also a B slot. These slots are so helpful because they remind me that, oh yeah, I need to square that whole -2. In fact, here, without the parentheses, it would be incorrect. I need the parentheses there. The next slot is an A, that's a 4, then a C, the -1. I'm just glancing back up at the formula, and the bottom slot is an A. So it's a couple B's, and then an A, a C, and an A. If you just do this every single time, you'll be more likely to avoid mistakes. Okay, well here are the answers. I just need to clean this up. And so I just have a few math steps to work out. The way I think of it is that I'm always just cleaning up 3 different pieces. I've got kind of this front piece here, I've got the square root part, and I've got the denominator. Of course, it's the square root part that's the messiest. The front part, those 2 negatives plus out, and so I'm left with just a 2. Inside the square root, let's see, I have -2 times -2, which is 4. And then that next part, I always just try to work out in one piece here. I've got a minus and another minus, and so I know those are going to plus out. So I could do that. I could even write it right on here. Those 2 guys plus out, leaving me then with just plus 16. And then in the denominator, I have an 8. If there had been 3 negatives here, the built-in minus and 2 negatives from these guys, 2 of them would have plussed out, but I would have been left with that third minus down here. Okay, so now let's see, we can do the 4 plus 16, of course, which makes 20. We're closing in now on the simplification. Sometimes you'll get to this point and you'll be done. There won't be anything else you can do. In this particular problem, though, there are a couple things left that I can do. One that catches my eye is the square root, because I know that there's a perfect square that goes into 20, namely 4. So when I break that down, that gives me 2 plus or minus, let's see, square root of 4 is 2. The 5 stays left behind, and I've still got the 8 on the bottom. Remember, that fraction bar is long. It goes with the entire thing. Sometimes you'll get to this step and be done, though in this particular problem there is one last thing I can do. Now this is tricky. I can reduce the fractions here, but the only reason I can do that is because this guy here, and this guy here share a common factor, namely a factor of 2. It's all or nothing. So if it was only 2 out of the 3 that share the common factor, then you're stuck. You might have even been looking at this 2 over 8 back here and said, oh, I should reduce that to 1 over 4. That's no good, because this 8 applies to this root 20 as much as it does the 2. The only way you can simplify is if these 3 all share a common factor. If they do, you can go ahead and divide it out. So you're dividing that by 2, that by 2, and that by 2, leaving me with my final answers, 1 plus or minus, let's see, that 1 I don't need to write, square root of 5, all over 4. Here are the 2 final answers to the equation. Remember, the plus or minus just reminds you that you have 2 answers. And then just a couple of wrap-up comments here. My math lab in this section, some of the problems have a glitch where my math lab is accepting the unsimplified answer as a final answer. So you could put this in, it'll mark it right. That's not good, because I won't accept that, so you need to make sure you are practicing simplifying all the way down. If you're not sure if an answer is fully simplified, make sure and ask me about it later. And then the other comment, most of the problems in this section are asking you to put in the exact answers, but there are a handful that ask you for decimals, and they have a particular way in this section that they want you to do the decimals. Just read the instructions, but the instructions in my math lab say, first round the square root to 2 places. So I got that off the calculator, and then it says do the rest of the math and round that final answer to 2 decimal places. Of course, really there'd be 2 answers. I would have to do 1 plus 2.24 and then divide that answer by 4, and 1 minus 2.24 and divide that answer by 4. Here's what I got. You should make sure you are getting the same thing. Okay, let's try this quadratic formula thing again on another example. Again, it's just a quadratic equation. I'm trying to solve for x. First step, put it in the right format. Now this guy is a big mess with these fractions, so I need to clear the fractions. Looks like the LCD would be 6, so I need to come along here and multiply each piece by 6. Let's do that. I've got a lot of canceling that happens here. 2 goes into 6 3 times. Here 3 goes into 6 2 times. No canceling on the right. And then our equation is now 9x squared plus, I believe, 16, 8 times 2, equals negative 24x. Then I need to get that 0 on one side. I can do that by adding this 24x to both parts. When you do the adding, you want to make sure that you keep your terms in the order of highest exponent to lowest exponent. So first the x squared term, then the x term, then the plain old number. So my equation is now in standard form, no fractions, a is positive. I'm ready then to go to the quadratic formula. Let me write down my slots. Negative slot, plus or minus, square root, slot squared, minus 4, slot, slot all over 2 slot. You can always start that same way. Remember, the first 2 slots get B's. I forgot to write down my A, B, and C. A is the 9, B is the 24, and C is the 16. So 24s in these slots. Then it's an A, a C, and an A. And you can check me by referring back to the quadratic formula. Next comes the cleanup. Remember those three pieces essentially that we're cleaning up. So the front guy looks to be just a negative 24. The square root part, these are kind of big numbers. A calculator would probably help. 24 squared turns out to be 576. This time I only have the 1 minus. Nobody pluses out, so I'll write minus. And then 4 times 9 times 16, you could grab that from the calculator. That is, interestingly, also 576. The denominator comes out to be 18. Finishing off the square root, well, this is kind of interesting because inside the square root, I just have a 0. How do I finish this off? Well, the square root of 0, 0 is a perfect square. I don't even have to have the square root anymore. The square root of 0 is just 0. I now have negative 24 plus or minus 0 divided by 18. Well, if the square root turns out nice, you're expected to work this out all the way. I mean, you don't leave it like this. These are numbers you can figure out. And actually, adding and subtracting 0, they don't do anything anyway. So this whole part basically just disappears. The plus or minus part is meaningless. This is a very strange situation where I actually end up with only one answer. It's rare, but it can happen. All I need to do is simplify that fraction, and I'm done. I have a 6 that I can divide out of each part. My final one solution to this equation is x equals negative 4/3. Now I will tell you, if the answer comes out nice like this, where there's no square root, whether there's one answer or two answers, that is a tip-off that back here, the factoring method would have worked. In other words, we would have gotten off a lot easier if we just used the factoring method. It's hard to know that, though, sometimes at the beginning. The quadratic formula works every time, and so we did go through and get the correct answer. Let's try one last example here. Looks like this one is already in standard form. I have the 0, my a is positive, no fractions or anything. I can jot down my a, b, and c. It's the three coefficients, so 1, and then negative 1, and 5. If there's no number there, of course, there are always 1's present. And then we can fill out our formula with the slots. Same thing every time. Fill in the slots. Remember, B's in the first two slot, and then A, C, A. Same thing every time. Now we move on to cleanup. The front number is going to become a positive 1. Inside the square root, let's see, when I square the negative 1, I get positive 1. I have a single minus sign. 4 times 1 times 5 is 20. And then I have 2 on the bottom. 1 take away 20 is negative 19. And so right there, I'd be looking for instructions. Now, what do they want? Do they want real solutions? Do they want complex solutions? I didn't write anything down here. Let's assume we want complex solutions. If they wanted real, we'd just stop and say, sorry, forget it. But if we want complex, then we can do the I thing. That's actually the only thing left to do. 19 doesn't simplify any, but I can take that negative and bring it out as an I. And so my final complex solutions are 1 plus or minus I root 19 over 2. There's no simplifying that can be done here. I would have to have common factors in these three places, and I got nothing this time, so this is as good as it gets. If this had been one of those x-intercept problems, you know, where this 0 had started out with a y and we were trying to find the x-intercepts, we would have stopped right here and said, well, sorry, there aren't any x-intercepts. X-intercepts are real. We would only go to the I if we're instructed to work with complex solutions.